In this video, we're going to be taking a look at the Iinc instruction. This instruction is a little bit different from those we've considered previously because we notice that it has two operands. The first one, varnum, the second one, const. And that makes sense if we look at the meaning for this instruction. So we see over here to the right that this Iinc is going to add a constant to a local variable. So of course, it's going to need to know what that local variable is, where it is in memory, and it's also going to need to know what that constant is. As we can see from the highlighting in orange here, both the varnum and the constant are 1 byte operands. And so what that means, as we saw with our iStore instruction earlier, is that we can only store to the first 256 local variables, and that just comes from 2 to the 8th. And because our constant is going to be a signed value, that means our signed value, our constant, can be anywhere from -128 to +127. So we do have some limitations with this instruction just based on the fact that those two operands are 1 byte in length. And so before we look at the specific micro instructions, as we've done with previous instructions, what we're going to do is look at sort of the ISA byte stream, or our ISA level instruction stream. And so as we would expect, we're going to have 3 bytes because we have 3 pieces here. And so let me write this explicitly, right? So our ISA level instructions are bytes. So the first one that we're considering here is going to be our Iinc. So Iinc, and if I come back up here, we can see that the Iinc has a hex code of hex 84. So if we were just looking at the actual value in this first byte, it would be hex 84. Our second variable, our varnum, is going to be an index, and just like with our iStore variable, this is going to be indexed from the LV pointer. So indexed from LV, and we'll see that explicitly when we look at the sequence of micro instructions here in a second. And then of course our third one, our const, is just going to be our constant value. So this is our third byte of our instruction. And so our constant, as we said before, this is going to have some range of -128 to a +127. And actually, let me move this up here because we're going to be talking about our PC later on. So let's get rid of that, and we'll put that arrow up here. Because like we talked about before, of course, we're going to have instructions that had come before this. We're going to have instructions that are coming after this. We're just looking at sort of a snapshot of our ISA level program, the instructions that make up our ISA level program, which are stored in our method area. So with this in mind, we're ready to then look at our sequence of micro instructions. So what we can see here is that our Iinc is 6 micro instructions. So we have 6 micro instructions. And so of course, we can also say that's going to be 6 cycles through our data path. And as we talked about before, of course, what we're doing is we're adding a constant to a local variable. And that was from this table up here. And again, this can be found on page 4-16 in the notes on Canvas. So let's sort of, to help us out, remind ourselves that everything is sort of starting from going back to this main loop, which was just 1 line. So let's write that again like we had before. So our main one is just going to increment PC. So PC equals PC plus 1. We're going to initiate a fetch. And then we're going to go to, and in parentheses, MBR. And so again, remember, like we've talked about in several situations before, any memory load or write is going to take 2 cycles. That data is not going to be ready, or it's not going to be fully written until 2 cycles later, and that was talked about on page 4.6. And the main reason I'm saying that is if we're starting out with our PC, and let me just move this down a little bit. So our PC is pointing here, right? So our PC register has fetched that hex 84 into MBR. That hex 84 is going to be what's in this MBR here, and that's going to cause us to go to the start of our Iinc instruction. So this is going to be at address hex 84 in our control store. And so of course, remember, our control store contains our 36-bit micro instructions. We've also incremented the program counter. So at this point, the main one has incremented that, but the MBR hasn't been updated yet. So the MBR here is still our hex 84. 2 lines later, so we'll see this fetch here, which is initiated, is going to be available 2 lines later. So available, let's see if I can spell, so available, there we go, 2 cycles later at the start of Iinc 2. So with all that in mind, we can start looking at our six micro instructions that make up this Iinc sequence. So in the first one, again, our MBR is not ready yet, but we can see sort of looking ahead, we're going to be adding some things. So as we talked about before with our data path, anytime our specific data path of the MIC1 as the textbook calls it, anytime we're adding something other than a simple increment or decrement, H has to be one of those registers. So what we can do is we can go ahead and store our LV into H. So all we're doing here is taking wherever our LV, which is pointing to the base of the stack, we're going to put that into H. And so of course the idea is we want to combine that LV with our index so we can know where our local variable is that we want to adjust. So moving on to the next line, now that MBR is ready, right? So this fetch we initiated up here, now our MBR is ready. Like in a previous instruction we've considered, we see we have MBRU. So the U indicates that this is the unsigned version of our MBR. So we're treating this index as an unsigned value. And so that checks out with what we talked about before, right? Because we said it's up to 256 local variables. So we have that, and we're now adding that unsigned MBR to H. And so basically that MBRU plus H is now pointing at the local variable that we want to adjust, right? So that's pointing to that local variable. So we put that value in our MAR register. And the reason for doing that is this is some value in memory, and anytime we want to write or read our memory, we have to use that MAR MDR register combo. So we've put this value in our MAR, so the MAR register, our memory address register, is pointing to the location where we're going to be reading and later writing this value. So the first thing that we need to do, as I indicated there, is we're going to have to read this value in, right? So if we want to adjust it, we need to know what it is, of course. And unless it's the top of the stack, we don't already have that in a register, so we have to read that in. And so of course, this is a read, so like we talked about on page 4-6, that's going to take 2 cycles before that's available, and because this is our MAR MDR register combo, it's going to be available in our MDR register. So in the meantime, while we're doing that, while we're waiting for that memory read, we can work on our Iinc 3. And so in our Iinc 3, what we're doing is we are incrementing our program counter. So coming back up here, we can take this PC and the arrow, and we can now move this to point to our constant. So we're looking at our next byte of our ISA level instruction. And so we're pointing there, and now we're going to initiate a fetch. And so again, this is a memory read, so it's going to take 2 times before that is ready. So we're going to say this is not going to be available until 2 instructions later in Iinc 5. And that's going to be available in the MBR. And so I should come over here and write this is going to be available in MDR. And then for completeness, this first one, of course, would have been available in MBR as well. All right, so we've initiated the fetch of that constant. So then moving on to our next instruction, our Iinc 4, we're simply saying H is equal to MDR, right? So we finally had that read that we initiated up here. So let me erase it so I can highlight again. So we initiated this read up here. That's now available in MBR. So what we're doing in Iinc 4 is we're taking the variable we want to adjust and we're putting it in our holding register. The next thing that we're doing is, again, we're going to have to increment our PC. So we're incrementing our PC and we're initiating the fetch. And of course, if we come up here to our ISA instruction stream, we don't know what comes after this, but some operation is going to be coming after this. Maybe we're doing, for example, an IAdd, in which case that next byte would be hex 60. But we don't know. So there's some byte after that that eventually we're going to need to execute the next instruction. So we go ahead and do that, and we again initiate the fetch. And so the reason we've done that in that order, we'll come back to here in a second, but let's first look at our Iinc 6. So now the Iinc 6, what we're doing is we're taking our MBR. So this was actually available in the previous cycle, but we've waited till Iinc 6, which is fine because we've not had time for this fetch to write into MBR, right? So that's not going to happen. So I'll draw another arrow down here, and this is going to be available in whatever comes right after our Iinc 6. And so what we can see coming back to the Iinc 6, what we're doing is we are taking that MBR register and we are adding it to H. So remember, H had our variable, our local variable we're wanting to change. We're now adding our MBR, which remember, we fetched that MBR, which was our constant. So we're adding the constant to the local variable. We're storing that in MDR because we want to write it back into memory. Basically, we want to write it back to where that variable was. And it's going to be in the same place because we haven't updated our MAR. So the MAR is still pointing in the same place as it was before. So we've read that variable in, we've modified it, and now we're going to go ahead and initiate a write back. And so again, that's going to take 2 cycles until that's available. So let me draw that arrow a little further just for emphasis. So this is going to be available 2 cycles later. And so we see the final part of that Iinc 6 is now we're just going to main 1. And so this brings us back to our point of why didn't we do this Iinc 6, what we have here, why didn't we do that up here when our MBR was available? And so the answer is that we have to do this PC equals PC plus 1, and we have to begin fetching because this next line that's coming after our Iinc 6 is going to be our main 1 line up here. And so we can see in that main 1 line, what we have to be doing is we have to be going to an MBR. And so for that MBR to be valid, we have to give that full time to have been loaded. Whereas if we did that fetch in Iinc 6, this would still be the MBR associated with our constant. And of course, that wouldn't really make much sense to go to an instruction. Oh, we might get some error in our operation.